Assalamualaikum. Hi, I am Dr. Syahidah from Universiti Kebangsaan Malaysia. I am going to present the last section of this paper, which is the mathematical foundation of Abdul's third intuition. So let us recall what Abdul's third intuition is. It says that an odd number is a prime number if and only if it is not divisible by any smaller odd number. In this section, we formalize Abdul's third intuition as a foundational theorem, and then we refine it and optimize for computational purposes. So here is the theorem to represent Abdul's third intuition. This theorem says that we have a function denoted by O, which mapping all natural numbers starting from 1 to odd number. The odd number is given by 2i plus 1. And then the odd number is in P. That means the odd number is a prime number if and only if for every j from 1 to I minus 1, the values of OI mod OJ is not equal to 0. Whenever this term is not equal to 0 for all j, then OI is a prime number. So the formula of OI equal to 2i plus 1 is just a way of list all odd numbers, which is whenever I equal to 1, we have odd number 3. Whenever I equal to 2, we have odd number 5, and etc. Okay, so let us look at some example to illustrate the theorem. I am going to present two examples. The first is whenever I equal to 5, and the second one is whenever I is equal to 4. For I equal to 5, we need to consider all j from I to 4. So whenever whenever j is equal to 1, this term is equal to 2, which is not equal to 0. Whenever j is equal to 2, we have the value of 1, which is also not 0. And the same goes to the terms whenever the value of j is 3 and 4. They are all not equal to 0. And the theorem implies that the value of O5, which is an odd number 11, is in the set P, which means 11 is a prime number. On the other hand, whenever I is equal to 4, whenever we consider I is equal to 1, the values of this term is equal to 0. And therefore, from that theorem, the O4, which is the odd number 9, is not in P. Therefore, 9 is not a prime number. So we can see that the theorem provides a complete characterization of prime numbers among the odd integers. However, the computation of the values of OI mod OJ for all integer j less than I, sometimes it seems inefficient and complicated process. To address this, we introduce a refinement that limits the range of j without losing the correctness of the identification of odd prime numbers. And this leads to the following lemma. In this lemma, it says that in the test provided by the theorem, we don't have to consider all j from 1 to j I minus 1, but we may restrict j to those oj less or equal to the square root of OI. For example, whenever I is equal to 5, then the square root of O5, which is the square root of 11, is 3.32. Therefore, we may restrict j to 3 because we may limit j to 1 only because O1 is equal to 3, which is less or equal than the value of the square root of O5. So we only have to compute O5 mod OI for I equal to 1 only. Okay, the lemma refines the theorem by showing that it is not necessary to consider all j less than I to compute the value of OI mod OJ, but only by those up to the square root of the AI. Beyond this optimization, the condition can also be reformulated in terms of greatest common divisor, GCD, which provides a compact algebraic expression of Abdul's third intuitions. And this leads to the following corollary. This corollary says that let OI is the formula of the odd number. Okay, then we let Pi minus 1 is a value of the product of all OJ, where j is all integers from 1 to I minus 1. So then, the number OI, the odd number OI is prime if and only if the GCD of OI and this value is equal to 1. For illustration, I consider example whenever I is equal to 5, where whenever I is equal to 5, the value of Pi minus 1 here is equal to the value of 945. Since the GCD of O5 and P4, which is the GCD of 11 and 945, is 1, so O5, which is 11, is a prime number from the corollary. The complete proving of the theorem, lemma and corollary can be referred to our paper. And together, all of this theorem, lemma and corollary provide a rigorous foundation for Abdul's third intuitions. And that is all from me. Thank you.